4x plus 3 squared, and you have to be able to take a derivative of something like this. And the brief review here is that you have the power rule, you have the product rule, the quotient, the like what I call functions, basically like your e, ln, sine, cosine, tangent, all that stuff. And then you've got like the chain rule. And of course, they can be mixtures of all of the above. So what stands out to you here? What do you see in terms of like how to take a derivative of something like this?
To do chain rule and product rule.
Yes, and start with product rule here. So it's better if you can do this without like splitting it apart. I know some students want to write F and G. Really don't want to do that unless you have to for this. So if you can, this is where it really comes down to like your speed. But do you like to take the derivative of the first and keep the second, or keep the first, take the derivative of the second? How do you start this?
I think the formula I learned, it says take derivative of first. So a 2x minus 1 would be the first.
Okay, so we're going to use the power rule. As part of the chain rule, right? Like it's product rule. This one's really product, power, and chain rule. 3 times 2x minus 1 squared. To the inside function, which is 2. Keep the second, okay, plus keep the first, derivative of the second, 2 times 4x plus 3 times 4. Okay. Now, if you understood all that, that's fantastic. That's really a great start. Okay. And that's the speed with which you've got to do it to be able to do well on this in this test. Okay. The next thing that the answer in the multiple choice section, because they always have one like this, is that they factor. They factor out certain things. And I'm not sure how much you guys have been doing that in class. It really depends on the instructor there. Do you see some things that can factor out?
No, we can simplify.
Right. That simplify as a broad thing means to factor. Like you've got well, let's do it in pieces here. So there's really a 6 because you got 2 times 3, 2x minus 1 squared, 4x plus 3 cubed, plus you got the 2 and the 4, 8, 2x minus 1 cubed, 4x plus 3 to the 1. So what you have that you got to factor out between is you got the 6, the 8. Then you're looking at the 2x minus 1 squared, the 2x minus 1 cubed, and let's go to color here, and the 4x plus 3 squared, 4x plus 3 to the power of 1. And I assure you will get a problem like this where you do have to be able to factor some things out. So looks like 2 goes into 6 and 8. Between 2x minus squared minus 1, you got 2x minus 1. And between 4 plus 3 to the power of 1, you have a 4x plus 3. So you got to now write, well, what's left over? 3 times 4x plus 3. If you can see that, 2 times 3 gets you back to the 6. The 4x plus 3 gets you back to the plus 4. 2 times 4 gets you to the 8. We did not grab all of these, so there's a 2x minus 1 like that. And now you have to simplify inside parentheses here. 12x plus 9 plus 8x minus 4. This becomes 20x plus 5. And then you bring all the other stuff down. So your answer would actually be presented like this, AP. Okay, so to give me some feedback here, like what's your comfort level with going from derivative to this down here?
I'd say it's pretty good.
Okay, let me give you one to try then. And you can see here what you come up with. I won't make it any more difficult or less difficult. I'm just going to give you different numbers here. 5x plus 3 cubed times 3x minus 4 squared, something like that, maybe. So go ahead and work that out. Let me know if you got any questions along it. I'm just gonna look up some more problems for us to work on that I know will be helpful doing on the AP.
So should I do it on my own or are we doing it?
Yes, I'm asking you to work this one out. Ask me some questions if you got along the way, you know.
Wait, I think I got messed up.
Okay, have you taken a derivative yet?
Yes, but I
Okay,
think with exponent, I can tell you where I'm at if you wanna.
so I'll follow the same format that you said
Yeah,
you'd like to take the derivative of the first, okay? And then we're gonna keep the second. Does this look like what you have to start?
yeah, I have the exact same thing. And then I have
Fantastic.
plus 5x plus 3 cubed times 2 times 3x minus 4 times 3.
Yeah, that's great. So
Okay,
now
so that's
it's
correct.
just a matter. Yeah, this is correct, but this is not how it would be presented, which is why, I want you to factor out. Basically, you can see they both have a 3. They both have x plus 3 to the power of 2, the smaller exponent. They both have a 3x minus 4 to the power of 1. And if you could do that also, because that's something you're going to see. It's really worth practicing one time, and then we'll move on to some other stuff that you will see.
So like how would I simplify the cube? Do I just leave it as is?
You have to between like the 5x plus 3 squared and the 5x plus 3 cubed, you look and
Wait,
factor
you're
out.
cutting out. Your voice is cutting out.
Sure. So the smaller exponent is the one that you factor out. So in this case, you're going to factor out a 5x plus 3 squared.
Okay, so let me see.
And then you do the same thing for the 3x minus 4 squared and 3x minus 4 to the power of 1. You look for the it's
Okay.
smaller as your
Let me try.
How are you doing on this one?
Good. I think I just a lot to simplify, I think.
It sure is. And this is the reason to get that practice in, every day just to work on, a problem like this. You should have factored out something like 5x plus 3 squared, and then 3x minus 4 to the power 1. And it's like, well, what's left over? Should have something like a 5 in there, 3x minus 4, and then this other one should be a 2 and a
Oh, yeah.
3. Okay. And then the last step is to actually combine what's in here, which
But
it
then do I need to like simplify the squares, like the 5x plus 3? Do I need to like
nope.
distribute it?
No, see what you'll see in the multiple
Oh,
choice answers, it'll have all of this. It'll just have like the answers will be one will have like a 1 here instead of and a 2, or maybe a 3 and a 1, or a 1 and a or 2 and a 3. They're going to do some deceptive things there. That's why you've got to be able to work it all the way through and be able to get a final answer here. This part in parentheses, you get 15x minus 20 plus 10x plus 6, 25x minus 14. And then you bring everything down. 3x minus 4, 5x plus 3 times 3. And see, the issue, maybe your teacher said, hey, don't simplify your derivatives, or, leave it as, unfortunately on the AP, the derivatives are simplified, and especially in that multiple choice section there. All right. Any questions on that before we move on to another kind of topic here?
I think that's good.
Okay. All right. So you will get some sort of a quotient rule type problem. I'm going to start with kind of your basic one here, which is something where you've got some sort of like basically a line in the numerator, something like 5 minus 2x over 4x plus 7, something like this. Okay, so just a basic quotient rule. Okay, and you probably remember this. It might be an FG or U over V type. It's always the bottom function times the derivative of the top minus the top function times the derivative of the bottom. So just a minimal chain rule here, because you have a derivative of the inside function in a couple of these, and then over the bottom squared. Now, the reason I'm doing this is, again, because this is a point of emphasis. They tend to give you one where you have to simplify the numerator. Okay, and it's really not that difficult. It's just adding extra steps each time with this. All right, so you got 8x minus 14 for this one. What to do with this negative? I would suggest a 4. So that's minus 20x. I'm sorry, minus 20 plus 8x in the numerator. And this is a potential shortcut for you on the AP. When they're in this format, the x term always cancels in the numerator, always. Okay, so that's just end up being a number like this. Next, what they actually tend to do here is ask you for the second derivative, because they know that this works out nicely. When you want to find the second derivative with something like this, it's better to do a rewrite step here to turn it into power of -2, and then just use the power rule followed by the chain rule. So they would actually ask you for the second derivative to be 68 4x plus 7 to the -3 times 4, and probably is simplified. The numbers might not, because of the fact that this would be no calculator here, but still do. Okay, let's see here. 4 times 68, 4 times 70 is 280 less 8, 272 over 4x plus 7 cubed, something like that. Okay, so what is your comfort level with quotient rule?
I think like I don't find it difficult. It's scared. It's easy to get like messed up in it.
Very easy. Yeah, it's you make one sign error all the way through, it propagates all the way through. Okay, So, but you've got this down, but notice when it's in this format, it tends to be the one they give you, something like this. The terms always cancel. That's sort of your built-in check, just a number in the numerator. But like I said, because they know that, they often ask you for another derivative, which means you're using power rule and chain rule. So let me give you one to try here. I'll make the numbers a little smaller, a little handier here. So let's say it would say, determine, d squared y over dx squared if y equals something like 2x minus 1 over 3 minus 4x, something like that. Okay. But I'd like to take your first derivative and simplify it, and then I'll like to check that step before going on
Okay.
the second derivative, just to see that we're in the same spot here.
Wait, so for quotient rule, it's like f prime of x, g of x minus f of x, g prime of x.
So if you like doing the rules, I got all of them on there. It's the bottom g times f prime derivative of the top minus the top times the derivative of the bottom over the
Okay.
bottom squared. And notice I use words because it's easy to mix up. Is it f? Is it g? Is it whatever? Words seem to be more meaningful than the letters. But take a look at that. And this one does work out nice. Like I said, it's not crazy.
Is it 2 over 3 minus 4x squared?
I believe that's correct. I was looking for some more problems. Yes. So keep going here. That's y prime. Go ahead and keep going and give me y double prime, please, which is notationally d squared y over dx squared.
Okay, wait. Is it 48 minus 64x over 3 minus 4x cubed to the fourth power?
That sounds pretty good here. Let me do the rewrite here in case you want to look at this later. 3 minus 4x squared minus 2 power. Okay, so your second derivative is 2 times negative 2 times 3 minus 4x to the minus 3 power times negative 4. I don't
Wait,
recommend
why is it to the minus 3 power?
you subtract 1 from the exponent,
Oh,
because when you bring it up, it's negative, and you subtract 1 from
oh.
there.
Yeah, then I messed up on that because I thought it would have been just to the first
Right,
power.
and it would be if it were in the numerator, but it's always subtract 1. We're practicing for the AP, so no big deal there. The coefficient, though, that goes out in front ends up being 16 over, looks like 3 minus 4x cubed, 2 times negative 4 there. Let me know when you get that down and we can move on to a new problem.
Yeah, I got that.
Fantastic. Okay,
Wait, but wouldn't
so
it be 3 minus 4x to the fourth power? Because
so
it's
we're
squared.
the first derivative here, 2. Okay, bring it up and it becomes -2. Let me make that a little cleaner there. It's -2 when you just rewrite it there.
No, but for the denominator, because don't you like square the denominator always?
You're not using quotient rule for this. If you
Oh.
can, so you can use quotient rule for this. It's unnecessary. That's why I did a rewrite in the practice problem, and then here I want you to do a rewrite step, because then you're using power rule. You avoid product rule. I'm sorry, quotient rule at all costs. Typically, you don't want to do quotient rule if you don't have to. If you'd like, I can show you how the quotient rule gives you the same result.
Okay.
Do you want more explanation on that, or are you
No,
okay
I
with
think
the
I
way
got
we
it.
left it? Okay, great. So some other types of problems you might see. Again, like we don't know what's on the test. We have no way to know. You know, it's like you just have to get your hands on any sort of practice you see and make sure there's not a problem out there that you're like, yeah, I have no idea how to do this. So here is one that maybe appears difficult, but there is, call it a shortcut, a trick, if you will. What do you see when you look at this? Again, it's asking you just to take the derivative. What kind of stands out to you
If
when you
you
look at
have,
this?
it's the ln rules.
Okay, I agree. So ln, the dx of ln of x is always 1 over x, or 1 over what's inside this. You'd write 1 over the square root. Does that sound right to you?
Yeah.
Okay, and that's kind of the standard way to look at this. If you do a rewrite, you can rewrite this as natural log 5 plus x squared to the 1/2 power, and logarithms allow you to bring that 1/2 out in front. So I've not taken a derivative yet. This is by comparison much easier as a derivative. If you do a 1 over root 5 plus x squared, you then have to take a derivative of the square root, then the inside function. So this is a common problem you'll see, where if you do this one little thing, you get something much easier. Okay, so the derivative here is keep the coefficient 1 over 5 plus x squared multiplied by the derivative of the inside function, which is 2x. So notice the 1/2 and the 2x, or the 2 there, they would cancel. So you end up getting x over 5 plus x squared, something like that.
Okay, yeah.
All right, so here's another type of problem you might see where, let me get this down here before I give you one, maybe to try on your own. You want to remember your logarithm rules, okay? And you might think, well, there's just so much to remember. It's like, yeah, there really is. There's a ton to remember here. Natural log ax squared over 2 minus x cubed, okay? And again, I would say, determine the derivative, right? Is there a logarithm rule property that you remember that might apply here?
Wasn't it just like the 1 over?
I'm talking about pre-calculus logarithm rules, things that help you to make this easier. Yes, you can do 1 over this, but look how bad this is. Then you got to do a quotient rule derivative. So let me quickly review some logarithm rules here. We already saw one of them, and these apply to both ln and log. Okay, log has base b, ln is log base e, but they apply. So if you have natural log of x to the n, this equals n natural log of x. Okay, and we used that in the last problem here. Natural log of a times b, so a product, becomes the natural log of a plus the natural log of b. A product becomes a sum. The one that most applies here is the natural log of a divided by b equals the natural log of a minus the natural log of b. These are used throughout math, science, engineering, physics, etc. You can't ever forget this stuff, especially on these standardized tests. This problem is designed, this problem can be done in like 30 seconds if you know this stuff, because once you break it apart, you realize how easy the derivatives are. Okay, whereas right now it's 1 over this quotient rule, product rule, I'm sorry, chain rule, etc. So does that kind of get you thinking about something from the past? Do you see how to rewrite this now?
Yeah.
Okay. So let me show you how I see it. Natural log ax squared minus natural log 2 minus x cubed. You see that?
Yes.
Okay, so the quotient becomes the difference. That's this third one here. But wait, there's more. There's more that we can do. Okay. The first one is also a product, so it becomes natural log of a plus the natural log of x squared minus the natural log of 2 minus x cubed. So that's using that second rule. And then we can use the first rule, the fact that these exponents, it doesn't matter whether it's inside here or here, it can go in front. Okay, so this becomes natural log of a plus 2 natural log of x minus 3 natural log 2 minus x, like that. And now you can take a derivative. You know, you've got it. It is the 1 over x. Okay, but there's a little bit more here. I didn't say this from the beginning, but a is a constant. All right.
Okay.
So you gotta be careful, because the natural log of a, the derivative of this is, what's the derivative of a constant?
0.
0. And the natural log of a is a constant, like ln of a constant. Pick your constant. Natural log of 5 is a number. So the derivative of this, when you're finally ready to do it, is 0 plus 2 over x minus 3 over 2 minus x, and then chain rule, derivative of the inside is -1. 2 over x, that negative, it could go a couple of places. It could go here, it could go down here. So a couple of ways that this could be written. It could be written as plus 3 over 2 minus x. That's kind of option 1. That's with the negative going to the subtraction symbol. Alternatively, you might see it as something like this: 3 over x minus 2, where it actually goes down into the denominator to flip it.
Okay. What other LN rules are there?
That's essentially it. I mean, there's a few other things like ln of e is 1, natural log of 1 is 0. The mistake is to think everything you've learned before doesn't apply. It's like, no, these things all come back. You'll find that some websites have like posters with like all the math rules. These are things to just study and scan to help you out here. All right, so let me give you one to try here, if you don't mind. Won't make it as difficult as this, but something to apply some of these rules here. And let's switch it up. We've not been using enough different letters here. This is a t. Let's go natural log 3t minus 1 to the 4th times 7 minus 6t cubed, like that. Okay. So again, at first apply your logarithm rules. I'd like you to work this one out, and then go from there. So take your derivative.
Okay, so is it me or is that going to be really, really long?
Nope. I mean, you've got a product. Product becomes a sum. You got a power. You're gonna bring it out in front. If you think these are long, I mean, the free response questions are really long. I mean, they're
Wait,
very time consuming.
wait, can you help me? Like, where do I even? start like,
Natural log of A times B is the natural log of A plus the natural log of B. A represents this 3t minus 4, 3t minus 1 to the
okay,
fourth.
okay,
B
then I think I
represents all of
can.
this. Yeah, and it's good that you asked
Okay.
because like it looks overwhelming. It's really not. It's really like a good question to get.
Isn't this mainly like you said, uh, like pre-calc? Like
No,
what?
no, because I'm asking you to take a derivative. The question would say, what is y prime of t? And if you don't know your logarithmic rules, you will go 1 over 3t minus 1 to the power of 4, 7 minus 6t cubed. Then you will use product rule over here with chain rule and power rule, and you'll get something that isn't in the answer space, and you're going to wonder why. So most of calculus that you're doing AB is really calculus based on the things that you've learned in pre-calculus and some of the trig. Okay. So this is
Okay,
a
but can I just tell
this
you where I am and you tell me if I'm
sure.
correct?
Yeah, of course.
Okay, so I got so I did like the ln 3t minus 1 plus
Yep.
ln 7 minus 6t cubed.
Good.
And then I brought out the exponent, so it'd be 4 ln 3t minus 1 plus 3 ln 7 minus 6t.
Yes, perfect. And that's what you're
And then
supposed
it'd
to do.
be
Now you
4
can take,
times 3 over 3t minus 1.
okay. Anything else?
And then it'd be times 3, right?
Yep.
And then plus 3 over 7 minus 6t times negative 6.
Good.
And then simplifying.
Yes. So
Should I still
12
simplify?
over, you'll want to scan the
How
answer
far do I
space.
need to simplify for the FRQs?
You don't, none, as far as I know. It's the multiple choice where this is more applicable. The FRQs are challenging because they go back and forth between derivatives and integrals, and then you sometimes have a calculator, so sometimes you're just throwing them right in using nderiv. I'm focusing on this as more of a mechanical, like can you take derivatives of everything that you ever see? But you'd have to look at the multiple choice. Because again, one multiple choice might have like minus 12 and positive 18, or switching the bottoms, or something else. But it'll be presented like this. It won't be presented as a 1 over multiplied by a product rule. So the answer is it depends. I hate saying that, but it really does. It depends on whether it's multiple choice, free response. Free response, no, you do not have to simplify.
Mhm.
Okay. Any questions on this before we transition to a related derivative thing?
I think I'm fine.
Great. All right. So here is a problem that you sometimes see that's completely related to what we just did. What is the derivative? Again, all of these are what are the derivative, like x to the sine x. Okay. And when you look at this, you're like, it's not a power rule. It's not a function because I don't know that. What do I do? What's the, and this is where those natural log properties come in again. Do you remember seeing problems like this at some point in the class?
Yeah.
Okay. So you take the natural log of both sides, and what that does is it allows you to bring the sine x out in front. This becomes natural log y equals sine x natural log of x. Again, no calculus yet. We're just using pre-calculus stuff, but now you can take a derivative. On the left here, you get 1 over y times y prime, or dy dx. On the right here, it's product rule. Derivative sine is cosine x, natural log x, plus sine x times 1 over x. And then if you saw this in class, you know that the last step here is to multiply both sides by y. So your original function is always in the answer. And because y was equal to x sine x, you plop that back in.
Okay.
Okay. Any questions of this? Because I like to give you one to try. It'll be slightly different, won't be an X, but it'll be same
I
setup.
think I got it.
Okay. All right, so here we go. Let's say y equals sine x to the cosine x. Something like that. Same steps, just different answer.
So okay, so would it be like sine x to the cosine x times ln sine x times sine x again?
As your derivative, like, or you give me your
Yeah.
final answer.
So sine
Yes,
x to the power of cosine x,
yes, that's true. And then what else
and
you got?
then times ln of sine x.
There's a bit more here. There's a tiny bit more here. So let's just go and see where you went here. I'm sure you did this. Natural log of y equals cosine x natural log of sine x. Is that's probably where you've got that line down. Is that right?
Yeah.
Okay. This becomes 1 over y prime equals, so this is product rule, right?
Mm.
Derivative of cosine is sine x, keep the second. I'm sorry, derivative of cosine is minus sine x, keep the second. Plus cosine x, derivative of natural log of sine x is 1 over sine x times the derivative of sine x, which is cosine x. My guess is you missed the chain rule part of that second derivative from what I heard. What do you see?
Yeah, I just got like complicated. It got complicated.
It did, yeah, it did. And it,
But
it was a
why
little,
do you do the ln of y? Like, what's the need of it?
you don't have a rule for a function to a function. Your
Okay.
rules are,
So
power,
they have like
chain,
exponent rules.
cosine x is not an exponent. It's a function.
Okay.
It's also not just an x, like 2 to the x is just x. If you remember, there's a rule for a number to an exponent variable. This one is a function to a function. All right, so there's just
We
a,
got
go ahead.
like this derivative review worksheet. It's extra credit, but it's more of just review. Do you want me to send it over?
Sure. We got a little bit of time left. We can absolutely get that. I was going to do some L'Hopital's rule next, but we can absolutely move on to whatever you would like. If you want to send it over by email, text, or drop it in the chat, I can take a look. While I'm doing that, there's just a tiny bit more here to do here. Cosine x, you could put it as cosine squared, or cosine over sine x is cotangent x. They do expect you to know that. I know it's not great. There's just so much to remember. They might also reorder this where where the positive one is first, so the cotangent x cosine x is first, and then you're multiplying it by y, which is the sine x to the cosine x here. That would be your complete derivative.
It's not letting me like. Wait. Do you know when we're meeting again?
We don't have anything currently scheduled.
Okay, then I don't know if I'll be able to get it to you in time, so maybe we could do it like another.
Sure. Yeah. So I've got some problems here ready to go. I'm going to just keep picking stuff that's new-ish for us. Let me grab a
Okay, I
snippet of
think I
this.
emailed it to you, but I don't know if you can access it. So,
Okay.
alright.
All right. Yeah, if it's come in, I'll take a look. Otherwise, we'll move to another problem here. So we're not using up precious time here today. There's a problem, but let's see here if it's coming. There it is. All right. Yeah. So you sent something your web view, something on your SharePoint. We'll see here.
Yeah, because she uses OneNote to give us the like things. I don't know if you can access it.
Unfortunately, it's asking me to log in, and you probably want to try and print that as a PDF here. So let's take a look at question 12 here.
Okay.
So this one appears to be something you're like, oh, this is stuff from earlier in the course, and it kind of is, kind of isn't. You always try putting the number in. You should plan on it not working. 6 to the 0 is 1, 2 to the 0 is 1. This is 0 over 0. This is called indeterminate form.
Okay.
Okay. And that means you have to use L'Hopital's rule, which
It's
I can't really
basically
remember.
find the derivative of what is
Exactly.
it?
The top and then the bottom. Okay. Bottom is pretty easy. Derivative of the bottom is 1. 6 to the x, it's like, what's 6 to the x? It's 6 to the x natural log of the base minus 2 to the x natural log of the base. All right, so that's one we haven't covered yet today. You can see it does work. And this time, though, when you put 0 in, you end up getting 6 to the 0, which is 1, natural log of 6, minus 2 to 0, which is 1, natural log of 2, which equals natural log of 6 minus natural log of 2 over 1. This may or may not be on there. This might be another one of those derivative natural log rules where it's 6 over 2, which it ends up being the natural log of 3. So again, that just is something to pay attention to. You might get the right answer, but it may not be in the form that you expect, and then you're really frustrated. So been there. All right. So here, one more here. We don't have a ton of time here. Go ahead and try this one, please.
Okay, so it'd just be cosine x over e to the x, right?
You're making the classic mistake of not trying the number first. You have to try the number first, because sometimes they just
E
work.
to the 0 is just 1, and okay.
Yes. So this one doesn't even apply because it works. So that's another thing to be on the lookout for, is like, what if it works? All right, so this one, I believe, yeah, this one you do have to work out. Tangent of 0 is 0, 0 plus sine of 0 is 0. This is indeterminate form. So you do have to take the derivative of the top and the bottom here.
So wouldn't it just be secant squared x?
The
Wait,
numerator
secant
is secant
squared
squared
of
x.
0, which is
Secant
is
is 1 over cosine
it is
squared. So
1?
it is just 1.
Yeah.
And then it's 1 plus 1, which is 2. So it ends up being 1/2.
Okay.
All right. All right. Well, that's going to take us to the end of our lesson for today. I'm going to go ahead and stop the recording.